Hello, in this video I'm going to be going over Charle's law. Charle's law is volume 1 over temperature 1 equals volume 2 over temperature 2. This is a direct relationship between both volume and temperature, which means that as temperature goes up, so does volume, or as volume goes up, so does temperature. So when one goes up, so does the other. Important to know about Charle's law, or any gas law, is that your temperature has to be in Kelvin. Why does it have to be in Kelvin? Well, first of all, Kelvin is based off of the movement of molecule, kinetic energy. 0 Kelvin is when molecules are stopped. They are not moving. Whereas Celsius is based off of the freezing point of water. When talking about gas laws, what would be more helpful? Not really the freezing point of water. What would be very helpful is kinetic energy, the movement of molecules. Because really, Charle's law is saying the faster molecules move, the greater the volume it will encompass. Which is, as volume increases, temperature increases. Perfect example of this would be when you're driving a car and you're looking at your tires. They are going to be flat or deflated more so in the winter months as opposed to the summer months. Why is that? Because when it gets colder, your temperature is decreasing, therefore a direct relationship would say that your volume also decreases and it becomes more flat. Whereas when it gets warmer in spring and summer, the temperature increases, so then the volume would also increase and it wouldn't be flat at all. Usually I always fill up my tires with more air in the fall because they get flat when the temperature starts getting colder. Alright, let's stop the chit chat and move on to an example problem. Why not start with question 1? It's right there waiting for us. It says a sample of nitrogen occupies a volume of 250 mils at 25 Celsius. What volume will it occupy at 95 degrees Celsius? So again, just like Boyle's law, how I set it up is I write my volume 1, my temperature 1, and I figure out what those even are. So let's say it looks like my volume 1 is 250 mil, and my temperature 1 is 25 Celsius. And we're going with our volume 2 and our temperature 2. Give me my temperature 2 as 95 degrees Celsius, and my volume, a sample of nitrogen, says what volume. So I'm looking for volume. Alright. Key to know, this is the common mistake that people like to make all the time, is they leave their temperature in Celsius, but that is a no-no. Can't do it. Got to convert it to Celsius, or you got to convert your Celsius to Kelvin. And you do that by adding 273 to your Celsius number to get Kelvin. If you can't do addition in your head, it's totally okay. That's why you bring your calculator to class each and every day. Alright. 273 plus 25 equals 298. 298 Kelvin. And I'm going to add 273 to my 95 Celsius to get Kelvin. 5 plus 273, 368 Kelvin. Alright, now I can plug and chug. So, using V1 over T1, my volume 1 is 250. My temperature 1 is 298. And my volume 2 is, I'm not sure, so I'm looking for. The temperature 2 is 368. Alright, multiple ways to solve this one. This is just algebra 1. You could either take 250 divided by 298 and then multiply both sides by 368, or you could do that fancy little trick called cross multiplying. That's the way I like doing it, so I'm going to show it that way. But you don't have to do it that way if you don't want to. Alright, so cross multiply means I have 298 and I'm multiplying it by my V2. 298 multiplied by V2. Let's zoom up on that. It's looking a little small. I'm then going to cross multiply my 250 times 368. 250 times 368 gives me a really big number. It's like 92,000. Alright, now we have like 298x basically. I'm going to divide both sides by that 298 to isolate my v2 or my x. Right. Divided by 298 gives me 308.7. v2 equals 308.7. I just need to double check sig figs. 250 looks like that has 2. This has 2. 95 has 2. So I need to have 2. I'm going to round this 8 up to a 1. It gives me 310. I'm not sure what my units for volume are, so I'm going to double check. What did I have for units right here from my volume 1? I had 250. No. I had milliliters. That was my unit. So 310 milliliters is my final answer, and that's how you use Charle's law to find the unknown volume.